This is part 2 of section 4.2. In the last video, I had a mistake when I was first trying to create that equation. I had the ordered pairs 2, 6, 4, comma 17. And I used this as my x1 and y1, but when you look at, we had this for our slope, and we said that we did 3,297 minus 2,164 over, what is that, 2020 minus 2017. Notice this is y sub 1 y minus y sub 2, x sub 1 minus x sub 2. Notice my x values are the years, and I have that as the y value here. So I need to switch that. And now this is x1 and this is y1. So with my formula, y minus 2,164 is equal to 1,033 over 3x minus 2017. Okay, so that is y minus 2,164 is equal to 1,133 over 3x minus, let's see, 1,133 times 2017. That gives me 2,285,261 over 3. Then I need to add 2,164 to both sides, put that over 1, multiply that times 3. So y is equal to our slope minus, okay, this will be 2,85261 plus, this will be all over 3. Okay, so 2,146 times 3, 6,492. Go over here. Okay, so now we've got y is equal to our slope. Okay, then minus 2,278,769 all over 3. Okay, now this is the correct equation for the data that we have here. So now we can go and plug in 12 for our x value and figure out what the population is in 2012. Okay, so it looks like that's 1,133 times 4. 12 divided by 3 is 4. Minus, let's go ahead and get a number for that. So I get 759,589.67. Okay, so then we have plus 101 or 1,133 times 4. Whoops. Almost made another mistake right there. This would be 2012. So this wouldn't just be 4. Okay, so 2012 times 1133. I'm going to go ahead and divide that by 3. And I get 759,865.33. Okay, now I'm going to subtract those two numbers, and I get 275.66. Okay, and since we're talking about population, I can't have 0.66 of a person, so we'll just round up to 276. So in 2012, 276 people were attending that school. All right, let's look at this one. Suppose Ben starts a company when she incurs a fixed cost of $1,250 per month for the overhead, which includes his office rent. His production costs are $37.56 per item. Write a linear function C where C of X is the cost for X items produced in a given month. Okay, so we have C of X. So he has an overhead fee, so fixed every single month, an overhead fee of $1,250. And for every item he produces, it costs him about $37.50. So plus $37.50 per item, and we're going to let item be X. And that would be your equation or your linear function C for the cost per month. Now, if you wanted to figure out how much would it cost you to say to produce 100 items, all you would have to do is substitute 100 into this formula. Okay, so that would be 1,250 plus, that would be 3,750. Then if you add those together, you would get 5,000. So it would cost him about $5,000 per month to produce 100 items. Okay, let's look at this one. Marcus currently has 200 songs in his music collection. Every month he adds 15 new songs. Write a formula for the number of songs in his collection as a function of time, t, the number of months. So t is the number of months. How many songs will he own at the end of 1 year? Okay, so we're looking for the number of songs in his collection. So we'll say number of songs. So n of t, and the number of songs he has depends on the time. Is it 1 month, 2 months? Is it a year from now? So this is equal to, all right, he starts off with 200. So he already has 200. And then plus, for every month, he gets a new song, or 15 new songs. So 15 times t, which t, remember, is the number of months. So there's our equation. And then it asks, well, how many songs will he own at the end of 1 year? Okay, well, 1 year is the same thing as 12 months. So the number of songs in 12 months, we just plug that in, 200 plus 15 times 12. So that will give us 200 plus 180, and that would be 380. So by the end of 1 year, Marcus will have 380 songs. So this would be our final answer.